Om Swastiastu, Assalamualaikum warahmatullahi wabarakatuh, Shalom, Om Namo Buddhaya, salam sejahtera untuk kita semua, dan salam harmoni. Okay, everyone, and welcome to my channel. On this occasion, we will discuss relationship and function. But before that, allow me to introduce myself. My name is Welzeen Sinaga, with name 2213101012, and I am from to EK class. So the learning topics that we will speak about in this video are 1. Properties of relation, 2. Equivalent relation, 3. Relation which is function, 4. Inverse of function, 5. Surjective function, 6. Injective function, and the last 7. Bijective function. Relation and function. Relations in mathematics are defined as the relation between a member of a set and members of another set. Sets A and B are said to have a relationship if there are members of the sets that are paired with each other. For example, the set A is the domain, the set B is the codomain, and the set of elements that get point to in B or the actual values produced by the function are the range, also called the image. So, and we have domain 1, 2, 3, 4, codomain 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the range is 3, 5, 7, and 9. Property of relation. 1. Reflexive and irreflexive relation. 2. Symmetric and antisymmetric relation. 3. Transitive relation. So 1. Reflexive and irreflexive relation. A reflexive relation is the one in which every element maps to itself. For example, suppose A is equal to 1, 2, 3, 4, and the relation R is the relation less than is equal to defined on the set A. Then R is equal to 1, 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, 3, 3, 3, 4, 4, 4. It can be seen that 1, 1, 2, 2, 3, 3, and 4, 4 are elements of R. So thus R is irreflexive function. Reflexive relation. An irreflexive relation is a relation in which each element does not map itself. For example, suppose A is equal to 1, 2, 3, 4, and R is equal to 1, 1, 1, 2, 3, 3, 4, 2, 4, 4. R is not a reflexive relation because 2, 2 is not included in R. Symmetric and antisymmetric relation. Symmetric relation is a relation is said to be symmetric if it has two elements A and B from a set. If A is related to B, then B is related to A. For example, given the set P is equal to 1, 2, 3. We find the relation R on the set P with R 1, 1, 1, 2, 1, 3, 2, 2, 2, 1, 3, 1, 3, 3. The relation R is symmetric for every xy element R. So, yx element R. Antisymmetric relation. A relation is said to be antisymmetric if it has two elements A and B from a set. If A is related to B and B is related to I, then A is equal to B. For example, show that the relation less than is equal to is one that Z is antisymmetric. The answer, it is clear that if A less than is equal to B and B less than is equal to A means A is equal to B, so the relation less than is equal to is antisymmetric. For the next transitive relation, a relation is said to be transitive if it has three elements A, B, C of a set. If A is related to B, B is related to C, then A is related to C. For the example, let A, B, C, and R is equal to AA, AB, AC, BA, BB, BC, CA, CB, and CC. So then R is a transitive relation. The next is equivalent relation. It is known A is equal to 1, 2, 3. A plus A defined relation R1 is equal to 1, 1, 1, 2, 2, 2, 2, 1, 3, and 3. What is an equivalent relation? An equivalence relation is a relation that is reflexive, symmetric, and transitive. The answer, uh, it is reflexive because 1, 1, 2, 2, 3, 3. Symmetrical 1, 2, 2, 1. So A relation B, B relation A, 1 relation 2, and 2 relation 1. Transitive 1, 2, 2, 1, then 1, 1. So A relation B, B relation A, then A relation C, or 1 relation 2, 2 relation 1, then 1 relation 1. So is an equivalent relation. Relation with its function. A function is a relation from set A to set B if every member of set A is paired with exactly one member of set B. All members of set A or their region of origin are called domains, while all members of set B are called codomains. The next is inverse of function. An inverse function is defined as a function which can reverse into another function. In simple words, if any function f takes x to y, then the inverse of f will take y to x. If the function is denoted by f or f, then the inverse function is then denoted by f accent minus 1 or f accent minus 1. If it's a function from x to y, so that it can be written y is equal to fx, then f inverse is a function from y to x, written x is equal to f inverse y. For example, fi to b is a bijective function. The inverse of a function is a function that combines its element of b with exactly one element of b. The inverse of a function is represented by f inverse as shown below. The next is surjective of function. The surjective function, or also known as onto, is a function that has the characteristic that codomain members might have more than one pair, but there might not be unpaired codomain members. Next is injective of function. An injective function is a function whose codomain member is only paired once with a domain member. In the injective function, the members of the set of codomains might not have pairs, but all members of the codomain that are paired there can only be one. There cannot be more than one. Injective functions are also called into function or one-to-one function because each element of the codomain can only be related once. The injective function can be seen in the following figure. And the last material is bijective function. The bijective function, or one-to-one correspondence, is both injective and surjective. In other words, each member of the codomain in the bijective function has exactly one primate in the domain. So, function A to B and function F C to D, it is bijective of function, but function A to F, it is not bijective of the function. Okay, that's all the learning that I can convey. Have a full, it is useful. If I have a mistake in pronouncing the word, I'm sorry. And I end with Param Santi. Om Santi 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 Om.